I'll be doing question 34, page 290. Okay, the question reads, a national equal employment opportunity committee is conducting an investigation to determine whether female employees earn as well as their male counterparts, with a sample of 75 males, 64 females. Yeah, information given to us in the table. Okay, so we let x1 equal male employees who pay in junior academic position. This shows. Okay, x2 is female, obviously, and easy marks. Okay. So what is given to us is that the N1 was equal to 75. N2, the sample is 64. X bar 2 and 1, which equals, given in the table here, 8, 5, 5. Is this it now? Yeah, for males, 8, 5, 5, 30, 8, 5, 8, 4, 6, 2, 6. Given a standard deviation of S2, S1, it's 1, 2, 18, and 1, 0, 2, 0. Okay, since here we are, from what I've seen so far, we are not told the standard deviation, so it's unknown and it's unequal since it wasn't stated in here. So therefore we will be using the Z formula for hypothesis testing of the differences in means. So okay, so we go into this okay, so H naught is mu 1 is equal to mu 2. H1 is mu 1 is greater than mu 2. Since they asked here, do males earn more than females? Okay, so go on to this test. Test that. Okay, this is the Z formula that I was talking about. Minus delta, apparently. Is 2 over n1. This is because okay, let's go to the rejection region of this. Any questions? Okay. Rejection. rejection region. Okay. So we reject H naught if our observes, Z observes, is we use this sign here. So it's greater than, which is the same thing. Oh, we're given an alpha of 5%, which is 0.04. So we put it here. Go to the table.
I have a question.
Yeah.
The S, is it squared or not?
It's squared, sorry.
And then with the N in the bracket, is it not 0 anymore?
Which one?
Of the normal distribution? Yeah, is it not 0
Oh.
anymore?
My bad. Okay, thanks. Okay. So here on the table, we use the inverse normal distribution table, table 2. We look for 0.95, which gives us 1.645. Okay, so we carry on and go to our calculation. Which is use these values here. Okay. It's 5.30
Sorry, why is alpha not divided by 2?
Given, if it's given, you don't have to divide it by 2.
But
But then they all
one tail.
One tail.
Yeah.
But explain what does that mean, Yasha?
Being one tail.
Yeah. Like how do you know something is one tail?
When it's one tail, it's because it's like it's either greater or less than. When it's two tails, can you like draw the
but then it's only not equal when you're concluding them.
Can you like draw
The reason why they didn't divide by 2
Is
is
it
because
not?
if you divide by 2,
Oh yeah. It's
I
not
remember-
equal.
I remember
It's two
also
tails.
because I
True.
also
On
raised
the
it
table,
out.
on the table.
It's because we usually get 95% level of confidence or something like that, but now it's only 5%. So we are able to look for it in the inverse,
the other table?
yeah.
Okay, what I think is that since it's one tail, right? Okay, can you draw the graphs? Like
Individual.
graph,
Let's go.
right? And if it's one tailed,
Yeah. Look at the
then we assume what I understand is when you have the H1, the what you call this? Okay, the tail of your sign should always face the rejection region,
Okay.
right? So in that case, we only have one sign, and that means we only have one rejection region, right? So that means where our sign is facing, where the tail of the sign is facing, is the rejection region. I find it very easy to like figure it out that way. So that means we only have we don't divide by 2. That means we don't have 2 rejection regions just because we have one sign and one tail. I think.
Or we could just read the book.
We'll just read the book.
I hope you answered now.
Yeah.
Okay, so let's carry on with this question here. Okay, so yeah. This is 0 for some reason. Can I ask why this is 0?
Each one is M1 minus M2. I mean M1 equal to M2. That means they are equal. So M1 minus M2 will be 0.
Okay, so we carry on. Okay. 1, 2, squared plus 64. Answer should be 4.5083 if I'm not mistaken. You guys can check it. And then we go on to the p-value. Can I erase this because I'm gonna run straight? Okay. Equals, use this one. So it's 5, 1. So the sign must face this way, right? There's a sign. Wait, let me check real quick. Yeah. So it's 1 minus P. So in the book here, when we look at our Z value, it ends at 4.09. And the answer there is 0.99998. So we estimate that our value here, our Z value, is 1, because we get closer and closer to 1 as we go on in the table. So we estimate 1 and we'll get a p-value of 0. And we'll conclude this. Okay. Since equal to 4.51 and p-value is 0 and set what is our alpha? Yeah. Alpha is greater than our 0. I'm not sure if the sign goes this way or the other.
No.
Left line.
With the line.
It's left line. It's the other side.
It's correct.
Reject. O. And then we use it with a 5% level of significance, LOS.
Right.
With a 5% level of significance, we have sufficient evidence to provide, to prove that male employees earn more than female. Thank you.
I'm not sure, correct me if I'm wrong. Like in class, there's a part that will say that the signs have to face the same side,
Yeah,
and the other ones, like for us to compute, the signs have to face the same side. And I don't understand how the z observed is 4.51, and then it's greater than. Then on the p-value, it's less than. Like, aren't they supposed to face the same side? Though it's
You
not
could
gonna
put
be.
the dash thing that I put initially.
But aren't the sides supposed to be the same? Like, okay, it confuses me because at first I thought they have to be like
Okay,
the same.
perhaps we don't memorize. How about that?
Yeah.
Yeah.
Okay, because I think if you're gonna memorize that signs have to face
Which way?
particular ways, we're gonna have problems because we're not understanding what we're doing. Ne? There's two things here. The first thing you need to note is that in step 3, which is your rejection region, ne? You are telling in advance, you're telling yourself that I'm going to reject my null hypothesis if this happens, right? So in his case, he's saying he's going to reject H0, which is this one, if what he observes, he hasn't observed anything yet, right, is greater than Z of alpha, which is the critical value, right? Okay, so in his graph, he's saying he has a rejection region, as you explained earlier on, Yash. If the Z observed exceeds this number, it means that the Z observed is falling in the rejection region. So he's going to reject H0, right? That means that if the Z observed doesn't fall in the rejection region, he'll fail to reject. Are we all happy with that? Okay, that's the first thing. So do you see that in step 4 already, in your calculation step, that you could make a conclusion without the p-value, right? In our case, that means that we've calculated this and we got 4.5083. Because we observed this number and our critical value was this number, what is our decision already?
We're rejecting H0.
You're rejecting H0.
Yeah.
So you're going to the p-value already knowing your decision. So your p-value always has to, what's the English word? Agree with the calculation that you have made. Yeah. Are we all happy with that? Okay? Is there anyone who knows the definition of what a p-value is? The probability of doing what? What's a p-value? What's this thing we're calculating in step 5? It's a probability of what? It's a probability of what?
The original Z is greater than.
Let's read the definition. What does the definition say in the module? What's the definition of the p-value?
Is the smallest form.
There, guys,
The
on page
smallest value
120.
of the smallest value alpha for which H0 can be rejected.
Okay? And then they say to calculate the p-value, we can calculate it by calculating the probability of rejecting H0 given that H0 is